Hi everybody and welcome back to the world of organic chemistry. This is Maria Thomas and today we'll talk about acetals, imines, and enamines. And this topic actually deals with your pi electrophiles that have hidden leaving groups. So we'll talk about some of the differences between these three groups as well as some of the little things to take note of. So let's jump to the big question. What exactly are we dealing with? Well, for these reactions, we can use aldehydes or ketones. And what's special about them? Well, they've got a carbonyl carbon, which is a pi electrophile. And you know what? It doesn't look like there are any leaving groups out here, just carbons and hydrogens. But actually, there is a leaving group here. It's just hidden from your sight. And that leaving group is actually this oxygen from your carbonyl group. Now, one of these could react with an alcohol and produce an acetal, or, in some cases, a hemiacetal if it only reacts once. It could react with a regular amine group and produce an imine. And finally, it could also react with a secondary amine and produce a structure called an enamine. And we'll talk about how to make these things, the similarities and the differences, all of that between these three groups in this video. So let's start with the reactions that form acetals. You've got your alcohol here, and you've got TSOH, which is actually just an acid. So it's important to note that these reactions happen in acidic conditions. And that means you can never ever form a negative charge. So the first step is always to protonate the oxygen, and that would give you this, which can now be attacked by the alcohol to give you your tetrahedral intermediate. But that has a positive charge and an extra hydrogen there. So let's go ahead and deprotonate that and get this structure, which is actually called a hemiacetal. It's like half an acetal, so it means we're just about halfway there. But wait a second, didn't we talk about a hidden leaving group? Where's that leaving group? Well, this guy, this oxygen, has now reached this point, and now we can actually make it a leaving group. Sneaky, sneaky. So now this hidden oxygen sneaky leaving group can go and grab another hydrogen from the solution and become the leaving group. And voila! There's your leaving group. So now we can collapse this tetrahedral intermediate and get rid of that sneaky leaving group to get this structure, which actually has a positive charge. But you can't really get rid of this positive charge by removing any protons, right? So what do you do instead? You can attack it with another alcohol to form a second tetrahedral intermediate, which we can now deprotonate to get our final product, which is an acetal. And all that means is that you've got two oxygens attached to the original carbonyl carbon, both of which have two R groups attached to the oxygens. Well, what about imines? Well, this reaction is almost the same, except that you have a primary amine instead of an alcohol. So let's go through the same drill again. Start by protonating the oxygen, and then attacking with your amine to get your tetrahedral intermediate. And let's deprotonate that nitrogen to get rid of the positive charge, just like we did with the oxygen last time, giving you this, which is, guess what? A hemiaminal, which is pretty much half of an imine, the same thing we did with acetals. And now our sneaky oxygen strikes again, and that's again going to become our next leaving group by grabbing a second proton. And there it is, the sneaky leaving group. So we collapse the tetrahedral intermediate and get rid of the leaving group again. But although this structure looks very similar to the last one, we don't really attack it with a second amine to get rid of the positive charge. Instead, we now actually have a proton which we can get rid of and form Your imine, which is the name of this structure that has a nitrogen double bond with a carbon group attached. And finally, enamines, which are almost the same except that now you have a secondary amine. And let's repeat the process one last time by protonating this to get this structure, which can be attacked by the secondary amine to get this tetrahedral intermediate, where we can alleviate the positive charge by deprotonation to get your hemiaminal again, where you have your Mr. Sneaky oxygen going and grabbing one more proton, finally showing its true colors as a leaving group. And so we make it leave and form a similar looking structure to the imine, but there's a problem. We've got a positive charge here and no protons to get rid of. At least none on the nitrogen. But there's actually a proton here, an alpha hydrogen, that you can get rid of, like this, to form this neutral compound, which is your final enamine. So what are some similarities between the three mechanisms? Well, all three of them use acidic conditions, which is why you've got a lot of protons floating around. All of them had a carbonyl carbon, which did not look like it had a leaving group. But this oxygen is actually the leaving group. It's a very sneaky guy hiding in there. And finally, what are some differences? Well, for an acetal formation, when you reach this stage, in order to alleviate that positive charge, you attack with another alcohol. For an imine, though, you've got an extra proton there, so you can just alleviate the charge by deprotonation. And finally, for an enamine, you actually have this alpha hydrogen, which you get rid of to alleviate that positive charge. And your final structure for an acetal looks like this, which is what you get when you use an alcohol. In comparison, the final structure of an imine looks like this, and you use a primary amine, which has two hydrogens, in order to make this. And finally, your enamine looks like this, and it is made using a secondary amine, which actually has only one hydrogen and two alkyl groups. And that's pretty much the gist of these kinds of reactions that involve pi electrophiles with hidden leaving groups. I hope this video was helpful for you guys. Thank you for watching.